Good morning, students. In today's session, we are going to discuss about double A linked list. Right? Here, in previous session, we discussed about what do you mean by single linked list. Right? Yeah. In single linked list is consisting of nodes. Right? Each node is consisting of data field and one is pointer field. One is data field and one is pointer field. Right? Here. Each node is consisting of data field and one more pointer field. Here, see here, node is there. This is the node. This is the data field, right? This is the pointer field, right? In pointer field, we are going to store the address of the next node. In pointer field, we are going to store the address of the next node. See here, for example, see here, I'll give one example here. Node 10, 20, 30, and 40, right? Null, right? This is header. In header, we are having the address of this first node. For example, 2010. We are having the information of first node. Right here, in this linked list, first no data address, data address, data address. We don't know the address of the previous node. We don't know the address of, for example, this is 10 node is there here. We don't know the address of the previous node, right? So to avoid such type of things, we are going to use this double A linked list. To avoid such type of things, we are going to use this double A linked list. In double A linked list, we are having two pointer fields and one is the data field. Here in first pointer field is going to store the address of the previous node. Second pointer field is going to store the address of the next node. Second pointer field is going to store the address of the next node. Here, for example, in linked list, we can traverse the list in this direction only. From left to right only we are going to traverse. There is no question of right to left. There is no question of right to left. But whereas in this case, we are going to use two pointer fields. That's the reason we can traverse this list from left to right and right to left. We can traverse the list from left to right and right to left. Right here, a double linked list is a two-way list because one can move in one direction, one can move in another direction. We can in double linked list we can move from left to right, or else we can move from right to left. Why? Because here we are going to use two pointer fields. One pointer field is going to use to store the address of previous node. One pointer field is going to store the address of the next node, and data field is going to store the address. Data field is going to store the information of that particular node. Data field is going to store the information of that particular node. Right here, in the same way, here also we are having the head node. Head node is consisting of information of the first node. Head node is consisting of information of the first node. Right, already we discussed that here. Generally, list, stacks, queues, all these are the data structures. So we can perform various types of operations on the data structures. Here, all these are the data structures. So we can perform various types of operations on the data structure. Here, what type of operations we can perform on the data structures? Just like insertion, deletion, traversing, searching, sorting. All these operations we can perform on the data structure. So double linked list is also the data structure. So we can perform insertion, deletion, traversing, and display the elements which are present in the linked list. Right, first one is the insertion operation. Here, insertion operation means we can insert any element into the list. We can insert any element into the list. Right, deletion means we can delete any element from the list. Display means displaying and visiting each and every node which is present in the list. Here, insertion means here we are having three types of insertion operations are there. First one is we can insert the node first at the beginning, or else we can insert the node at any point, given point, or else we can insert a node at the end of the list. Right, this type of three insertions we can perform on the double A linked list. In deletion also, we can delete the node from front. First node we can delete, or else we can give the position where we can delete that particular node, or else we can delete the last node of the list. Right, traversing display means we have to visit each and every element. We have to travel each and every element which is present in the list. Right, first one. Now we are going to discuss about how we are going to perform the insertion operation on the list. Right, insertion. For example, this is the list which is consisting of these elements 10, 20, 30, 40. right? Here we are going to use two pointer fields. One is the header field, one is the pointer field. Here both are pointing to the first node only. Address of the first node is 1010. See here, address of the first node in this left pointer field, we are going to assigning the null value here. We are assigning the null value for this one, right? Why? Because there is no previous node. There is no previous node is there. That's the reason we are going to assigning the null value to the left pointer of the first node. See here we don't have any right pointer. That's the reason we are going to assigning the null value to the right pointer field. We are going to assigning the null value to the right pointer field. See here 10. Now here for this 10, which is the next node, 20 is the next node. What is the address of the next node? 20. So we are going to store 2020 here. We are going to store here 2020, right? Next, see here 20 is there. For this one, for this 20, which one is the next node? 30 is the next node. What is the address of this 30,000? So we are going to store here 1000 here. Next node, address of the next node we are going to store in this place, right? For this 20, which one is the previous node? Previous node is 10. What is the address of the previous node? 1010. So we are going to store here 1010, address of the previous node. At 30. Now for this 30, which one is the previous node? 20 is the previous node, right? Here, address of the, here in left pointer, we are going to store the address of the previous node. For this 30 node, which one is the previous node? 20 is the previous node. So what is the address of this 20? 2020. So we are going to store the 2020 here. For the 30, which one is the next node? 40 is the next node. What is the address of this 40? 2000. So we are going to store here 2000. So here, in here 1000 node we are going to store this information, right? Next node is 40. For this 40, which one is the previous node? 30 is the previous node. What is the address of this 30,000? So we are going to store the 1000 address here in left pointer of the 40, right? Here for this 40, which one is the next node? There is no next node is there. So if there is no node is there, so there will be no address is there. Just that's the reason we are going to put here null, right? For 40, this one here, this list is there. This list is consisting of 4 elements: 10, 20, 30, 40. 10, 20, 30, 40. Here we are going to use one pointer field and one header field. In this pointer and header field, we are going to pointing to the first node address, that is 1010. Next, now I am going to inserting this new node 50. So while we are going to declaring this new node, so we have to assign null value to this one. We have to assign left pointer of this new node is null, right pointer the new node is null. New node is 50, which address location? 20, right? See here how we are going to creating this node here. See here, new node is there. Here new node data is item, that is 50. Right? Next PTR is header, already PTR is header, right? New node next is PTR, new node next is PTR, new previous is null, header is equals to no. See here, I am going to assigning here, I am going to this one, I am going to inserting this node at the beginning. So here this node is consisting of, what is this one? Here, see here, this node is there. Here my new node is 50. Right, my new node is 50, which address location? 2200 address location. Here, where we are going to inserting this node? At the beginning, we are inserting this node. So here, already I created this node. Already here I am creating this node. Right, already here I am creating this node. Just I want to insert the pointer field. Just we have to make the connection between these two. Just we have to make the connection between these two. How we are going to make the connection between these two? Here first node is 10. Now we are inserting at the beginning, means this 50 begins, 50 will become the first node. So see here, just we have to add here for this one, what is the address of this new node? 2020. So for this 10 node, which one is the previous node? This 50 is the previous node. So this 50 is the previous node, right? Just we have to make the address here. We have to save the address here. 2200 we are going to place here. Now this list is consisting of 50, 10, 20, 30 and 40. Why? Because here we are placing the, here for this 10, which one is the previous node? 50 is the previous node. We are going to save the address. We are going to save the address of this 50, the left pointer to the 10 node, right? Now here for this 50, is there any node is there? No node is there. So that's the reason here we are going to assigning the null value here. We are assigning the null value here. That's it, right? Now here always pointer field and the header field is going to store which information? Header information. So here in header we are going to save the 2200 header. What is the address of this node? 2200. So we are going to saving the address here in 2200. We are going to saving the address. This is the insertion at the beginning. In insertion of the beginning, first we have to create a node. Then we have to assign the null pointer value to the left pointer field of the new node, and we have to assign the null pointer to the right pointer to the next right pointer field of the new node. Then we have to create the link between the new node and the first node of the given first node which is present in the list. Then after joining the new node and the first node of the list, then new node becomes the first node of the given list. So this is the insertion at the beginning. Next one is the inserting a node at the end, right? See here, whenever we are going to insert any node into the list, it means that we have to create a new node. See here, I am creating the new node here, 15. Now, what is my address location? 2200, my address location is there. Now, here, we have to traverse the complete list. Whenever we are going to read the null value of the right pointer field of any node, it means that that node is the last node of the particular double linked list. Here, I repeat, here when we are going to say this list node is the last node, if we are going to reach the pointer field is null. Here right pointer field of the right pointer field of any node is null. It means that that particular list, it means that that particular list is, that particular node is the last node of that particular list. So here first we have to traverse from here 10. Here 10, we have to check whether we have to check that here this is right pointer field of this node is null. No, so it consisting of some element. So we have to go to that particular list, particular node. So 20. So check for the right pointer field. Right pointer field is null. No, here 1000 is there. So go to that list. Right here for this node, check this pointer field whether it is there, right pointer field is null or not. Here right pointer field is not null, so go to the next node. Right, check here right pointer field is null or not. Right pointer field is null, so we have to add at the end. See here now, so we have to write this 2200 for this one. We have to create the link between these two, right? We have to create the link between this node and this node. How we are going to creating this list between these two? See here, we have to create this one, right? Yeah, see now here in this case 50 is there, right? 50 is there. We are creating the link between these two. Here, what is now? We are going to save this in the right pointer field of that particular previous node is 40 node is. We are going to save the address of this new node. So 2200 is going to store in the address of that 40, right? Now here, for this 50 node, we are going to make the connection between this 40 and 50. Now for this 50 node, previous node, which one is the previous node for 50? This 40 is the previous node for the 50. So here in this left pointer field of the 50, we are going to save the previous node address. What is the previous node address? 2000 is the previous node address. So here we are going to save the 2000 here. Here in 40, we are going to store the address of the next node. What is the address of the next node? That is the new node 2200. We are going to save here. For this 50, this is the new node. For this one here, left pointer field, in left pointer field, we are going to save the previous node address. Here, which one is the previous node address? 2000 is the previous node address. So we are going to save the 2000 in this case, right? For this one 50, which one is the next node? Next, there is no question of next node. That's the reason we are going to put the null value here. That's the reason we are going to put the null value here. See here, create a node. First, we have to read this one. PTR header is that's it. Here we have to check PTR next not equals to null. Every time we have to make this one. Every time we have to make this one, right? Next is right here. New next. What is the new next is null. New previous is this one. This PTR. PTR is going to pointing to the 2000. So we are going to inserting this node, right? Next is here before inserting a node at position 3. Here we can insert any node at any given, at a given position. In this case, while we are going to insert any node at a given position, first we have to enter the position of that position of the node where we are going to insert. right? For example, I am going to insert this node at third position. So first of all, we have to create a node. See here, I am creating this node null. Here 50 node is there. This is the new node at 2200 memory location. I am going to creating one node. So left pointer of this node is null, and the right pointer of this node is null. So here at third position, see here, we have to traverse from this one. First we have to read this first position here, then we have to go for the second position, then we have to here, then we have to make this one. Here for this 20 node, which one is the next node? 50 is the next node. So we have to save the address of the 2200 here, right pointer of this one. For this 50, which one is the previous node? 20 is the previous node. What is the address of this 20, 20, 20? So we are going to save this one here. For this right pointer field, here for this one, which one is the next node for this one? Next node for this one is the here. For the 1000 is the next node, we are going to save here, right? For this one, which one is the previous node? Previous node is the previous node is 1000. For this one, here we are going to save this one. So here, in this format, we are going to save the, we are going to inserting the value, we are going to inserting the value here, right? This is the insertion after this one. Now, up to here clear? Now we are going to deleting the element at the beginning, right? See here, for first we are going to construct one list. This particular list is consisting of 10, 20, 30 and 40 is there. Now I am going to deleting the 10 element from the list. I am going to deleting the first node from the list. So here, whenever we are going to deleting the element first we have to delete that particular element, and we have to take one pointer field. That particular pointer field is going to be pointing to the first node address here. What is the first node address? 2020 is the first node address. So in this pointer field, we are going to save this one 2020. Now left pointer of the pointer field is null. Here left pointer to the first node is null. So we have to assign the null value. Then this node is going to be free. Right? Here first, how we are going to deleting the element? Here first PTR is, header is going to be, here I am going to save the header value in PTR. So PTR1 is PTR next. Now PTR is not equals to null, PTR previous equals to null. So just we have to assign the previous value is null. Then free that particular PTR. Now this is the PTR, we are going to free this PTR. So this is the deletion of the node. Now deleting the node at the end. How we are going to deleting this node? Here deleting the node means just we have to assign the null value to the right pointer of that particular node. Then that is the end of the list. See here first we have to traverse this list. Here first 2020 is there. This list is consisting of 10, 20, 30, 40 elements are there. First, this is the first node. So what is the address of this next node is 2020. So list is consisting of second node. Now 20 is there. We have to check whether the right pointer field of this node is null. No, this right pointer field of this 20 is 1000. So it consisting of one node. Go to this particular node, and we have to check this whether the right pointer field of this 30 node is null or not. Already 2000 is there, so it is not the last node. Check for this one, what is the right pointer field of this node is null or not. Here right pointer field is null. See here, just we are checking this one only. While PTR next is not equals to null, go to the PTR next. So we are reading from 1 to next. So PTR equals to PTR next. Now our PTR is 2000, right? Now and while now PTR1 is PTR previous. So PTR1 is PTR previous. Previous is 1000. So we are going to save this in PTR1. We are going to save the previous value. What is the previous value? 1000 is the previous value. 1000 is the previous value. So right, PTR1 next is null. PTR1 here for this one 1000 is the PTR1 next. What is the next value here? We are going to assigning the null value. Then we are going to free this one. Right. This is the deleting at the end. Before deleting any node at any given position, just whenever here, see here, I want to delete the third node, so we have to go for the third node. So just we have to create the link between these two, and just we have to create the link in between these two. See here, right? Instead of here, which node address of this node is 2000. So here I am going to say this 2000 here, right? What is the address of this previous node? Previous to node is 2020. So here I am going to save 2020. That's it. Here deleting any node at any given position. Displaying means we have to visit each and every node. in, in this forward order 10, 20, 30, 40 we are going to display in this one. In reverse order 40, 30, 20, 10 we have to reverse, we have to display the element in the reverse order. This is the double linked list. This is the double linked list, right? Now circular list. Here in circular list means here in single linked list, here what do you mean by single linked list? In single linked list we are having the nodes, right? Here, see here, in single linked list, this is the first node, right? Next is next node, 20, third node, fourth node. This is null value, right? This is the single linked list. Here in circular list means last in pointer field of the last node is going to save here. See, the linked list where the last node points to the header node is called the circular list. See here, everything is same. Everything is same, just like the single linked list. Only the difference is in circular linked list, just here pointer field of the last node is going to be pointing to the first node, right? Here in 10, here 10, in 10 what we are going to save here? Address of the 20 here. For example, at 101, see here, here 1020, 1040, 1060, 1050, 1060 is there, right? See here, in this case, here, in this pointer field, what we are going to save? Here, address of the next node. So here we are going to save the address of the next node, that is 1040, right? Here in 20, in pointer field, we are going to save the address of the next node, 1050. Here, in this case, address of the next node, 1060, right? Here, generally, if it is a single linked list, we are going to assigning the null value. But here this is the circular list. Here we are going to save the address of the first node. Here last node is going to be pointing to the first node of the list. So that is the circular list. Circular list is also the data structure. That's the reason it is also performing the operations insertion, deletion, traversal. Right? All these operations are going to be performed here. Circular double linked list means same here. Here previous node is there. Here it is going in the left pointer. In left pointer, we are going to pointing to the previous node here. For this one, which one is the previous node? Last node is the previous node. For this 10 node, which one is the next node? 20 is the next node. For this 20, which one is the previous node? 10 is the previous node. Which one is the next node? 30 is the next node. For this 30, which one is the previous node? 20. Which one is the next node? 40. For this 40, which one is the previous node? 30. Which one is the next node? First node. It is going to pointing to the first node. So circularly, there is no question of null is there. So this is the circular double linked list. Here, each and every operation is just like if in the circular double linked list, each and every operation is just like the double linked list operation. In circular single linked list, each and every operation is just like the single linked list operation only. Right? Now, with this linked list topic is completed. Here there are three types of linked list is there: single linked list, double linked list, circular list. In single linked list we are having only one data field and one pointer field. In one pointer field we are going to save the address of the next node. In double linked list we are having the one pointer field, two pointer fields and one is the data field. In pointer field, in left pointer we are going to save the address of the previous node. In right pointer we are going to save the address of the next node. Right? In circular list, here in circular list, in first we don't have the null value in any node. Here last node is going to be pointing to the first node, right? These three are the data structures, so we can perform insertion, deletion and traversing operations on these data structures. With this, the linked list topic is completed. Next one is the polynomials using linked list. How we are going to implement these polynomials, right? Generally here polynomials means here just like here for example 2x cube plus 3x minus 6. Now this is the polynomial equation. Now we are going to represent this equation by using this linked list. We can represent this equation by using the linked list, and here we can perform various types of operations on these polynomials by using the linked list, by using the linked list operations. Here each list node will represent the one term of the polynomial. For example, here 2x cube plus 3x plus 6 minus 6 is there. Here this polynomial is consisting of three terms. 2x cube is there, 3x is there, 6 is there. So here this 2x cube is going to represent by one node, 3 plus 3x is going to represent by one node, minus 6 is going to represent by one node, right? Yeah, 2x cube is going to represent by one node, plus 3x is going to represent by one node, minus 6 is going to represent by one node. Here now, here we are going to use one template. By using this template, we are going to implement this, implement this polynomials, right? Here how we are going to implement this one, by using the structures we are going to implement this polynomials, right? Here addition of the polynomial, how we are going to perform the addition of two polynomials. For example, to add two polynomials a comma b, we have to use two list iterators, means we have to use two lists. For example, if I want to add three polynomials at a time, so we have to use three lists, right? If we are going to use four polynomials to perform any operation, we have to use four lists, right? Here here in my example I am going to use two polynomials. That's the reason I am going to use two variables p comma q are going to be used to move along the term a comma b. A comma b are pointing to the two polynomials, p comma q are two variables. Why? Because here we are going to use two variables a comma b. That's the reason here we are performing addition of two polynomials a comma b. That's the reason we are going to use two variables p comma q. That's the reason we are going to use these two variables p comma q, right? Here exponents of two terms are equal, then the coefficients are added, right? See here, what is here? For example, here 2x square plus 3x minus 6 is one polynomial. It is going to represent by this a. Here 2x square plus 4x minus 6, it is going to represent by b. Here variables, here this p is going to represent this a, b is going to represent by this q. Here exponent, here 2x square is there, so x square here. Now in general, what is the answer for this one? Here 2x square plus 2x square, 4x square plus 3x plus 7x, 4x is 7x, minus 6 plus minus 6 is minus 12, minus 6 minus 6 is minus 12. This is the original answer for this one. Here we have to add the polynomials, we have to add the coefficient. Here we have to, the new term is created of the result if the sum of the coefficient is not 0, right? If the exponent of two terms are equal, for this one, what is the exponent for this one? X square. So this is 2, here also 2, so we have to add these two. We have to add these two. Then only if the exponents of the two terms are equal, then only the coefficient are going to be added. If any new term is created for the result, if the sum of the coefficients are not 0, right? Here if the exponent of the current term is a is less than the exponent of the current term in b, then the copy of the term b is created and attached to the polynomial c. For example, see here, instead of this one, here for example, here I am going to use one more variable, that is the 4x cube. Then what is my answer here? Plus 4x cube is there now, so we have to create one term here. So every time we have to check with this one, the exponent of this one, 3 and 2. Here 3 is greater than this 2, so we have to add first this 3, then we have to go for the 2, then we have to, here 7x power 1, then we have to check these 2, so 7x is there, go for the next one, right? Here the variables q is advised to next term, similar action is going to be taken. See here a, here for example 3x power 14 plus 2x power 8 plus 1 is there, so 3x power 14 exponent 14 here plus 2, so 2, what is the x power 8, so 8 here, then plus 1, so there is no term of x is there, so 0 0. This is the first polynomial. Second polynomial is 8x power 14, 8, what is the x power 14 is the x power is 14, so 14 minus 3x power 10 minus 3, so x power 10 is, see here, x power 10 is x power 10 plus 10, x power 6 is the 6. So we have to add these two polynomials. How we are going to, I am going to create one list. By using this list, I am going to creating this one. By using this list, I am going to creating this one. Right. First, see here. First, here 3x power 14 plus 2x power 8 plus 1. Here 8x power 14 minus 3x power 10 plus 10x power 6. C is 11 14. So in this format, we have to add these two polynomials, right? with this I am going to concluding this one. Here in circle list also, in this way same only we are going to represent this one. In next class I am going to discuss about how we are going to perform the searching operations, searching and sorting operations, right? Thank you.